For the longest time, network security was all about one thing: location. Your IP address, your VLAN, your physical port, that's what decided what you could and couldn't access. But let's be honest, in today's world of cloud and dynamic software-defined networks, that model is just, well, it's broken. Today, we're going to dive into how integrating Cisco TrustSec with SD-WAN completely flips that on its head, shifting security from where you are to who you are. And trust me, that changes everything. So, here's our game plan. We'll start by looking at why the old, rigid way of doing things just doesn't cut it anymore. Then we'll introduce the TrustSec solution and really break down how it works. After that, we'll get into the two key phases for deploying this on SD-WAN, getting the identity out there and then actually enforcing the policy. And to wrap it all up, we'll see how it creates this incredibly powerful end-to-end security vision.
Okay, so before we can really appreciate the solution, we've got to dig into the problem, right? Why did we need such a massive change in how we think about network security? It all comes down to how inflexible that traditional model really is.
So take a look at the top half of this picture here. This is the old world, the way things used to be done. Security was literally baked into the network design. We chop up the network into these segments called VLANs, one for employees, one for guests, and so on. And to control the traffic between them, we built these gigantic, super complex rule sets called access control lists, or ACLs. Your security was quite literally bolted to your network address. And as you can imagine, this old way of doing things, well, it causes some major headaches. Because your policy is tied directly to an IP address, it's incredibly rigid. It creates this tangled web of static ACLs that becomes an absolute nightmare to manage, troubleshoot, and scale. Every little change feels risky. And here's the real kicker. This model is completely blind. It has no clue who or what is on the network, only where they happen to be plugged in.
And this is exactly where Cisco TrustSec just walks in and flips the whole script. It introduces a totally new model. It's not about where you connect from anymore, it's all about who you are.
So it forces us to ask this really fundamental question. What if security had nothing to do with your network address? What if your access policy could actually follow you and your device based purely on your identity, no matter where you decided to connect from? And here's the answer. Now, look at the bottom half. That's the TrustSec model. Right in the middle, you've got the Cisco Identity Services Engine, or ISE. Think of it as the central brain of the operation. Instead of worrying about IP addresses, we give users and devices identity tags, simple labels like employee or supplier. And now the policy is based on those tags, which makes the underlying network topology pretty much irrelevant for security.
Okay, so that's the big idea. But how does it actually work? What are the nuts and bolts that make this whole thing tick? Well, let's break down the two core pieces that make this identity-based model a reality.
First up, we have the Security Group Tag, or SGT. The best way to think about this is like a digital name tag. When a user logs on, ISE hands them a tag. It's just a number, really, that represents their role. Maybe employee is tag 10 and an IoT camera is tag 25. From that moment on, that tag is that traffic's identity. And then there's the second piece of the puzzle, the Security Group ACL, or SGACL for short. This is your policy, but instead of a giant, confusing list of IP addresses, it's a simple, logical contract between tags. The rule is as plain as source tag employees are allowed to talk to destination tag app servers. It defines access based on roles, totally abstracting away the network itself. So when you put these SDTs and SGACLs together, the benefits are just huge. You get real software-defined segmentation that's based on business logic, not on how you cabled your network. And the policy becomes incredibly scalable. Instead of trying to manage thousands of IP-based roles, you're managing a simple matrix of group-to-group contracts. It's just a smarter, safer, and way more manageable way to control access. Now, this is all great in theory, but how do we make it work across a huge network like an SD-WAN? This is where that SD-WAN integration is so critical, and it happens in two main phases. The first phase is all about propagation, basically making sure those SGT identity tags can travel everywhere they need to go across the entire SD-WAN fabric. This slide really shows a massive evolution. Over on the left, you see typical SD-WAN segmentation, what we call macro segmentation. You've got these big, broad VPNs for campus traffic, guest traffic, and so on. But look at the right. With TrustSec, we can now do micro segmentation inside a single VPN.
We can use SGTs to create and enforce totally different policies for employees, contractors, and phones, even though they're all sharing the exact same network overlay. That level of granularity is a huge leap forward.
So how do we get these tags across the network? Well, there are two main ways. The first is inline tagging, and it's the most efficient. The SGT is just embedded right into the packet header as it zips across the SD-WAN. Simple and direct. But what about devices that can't do that? Maybe you have some older gear or third-party devices. For those situations, we use something called the SXP protocol. Think of it as a separate communication channel that just shares all the IP to SGT mappings between devices so everyone stays on the same page.
Okay, so we've got the identity tags flying across the network. Now what? That brings us to phase 2, enforcement. This is the fun part. This is where the policy actually gets applied, and we turn that identity into real action.
And this diagram shows it perfectly. So you've got a user with an employee tag, and they're trying to reach two different servers. Our policy matrix, those SGACLs we talked about, says employees can talk to app servers, but they absolutely cannot talk to production servers. So when the traffic hits the router just looks at the tags, checks the policy, and bam, drops the forbidden traffic. It's that simple, and it's all based on context.
And this is so important. These Cisco SD-WAN edge devices themselves are the enforcers. You don't have a bottleneck at some central firewall anymore. The intelligence is distributed right out to the network edge. The policy is applied right as traffic is leaving the device, which means enforcement happens exactly where it needs to. This makes your network more secure and more efficient.
All right, so let's pull back and look at the big picture, the whole end-to-end division, because this is where it all comes together. When you combine this identity-based policy with a smart SD-WAN fabric, you get something much more than just a secure WAN. You get a truly unified security domain. And this diagram just says it all, doesn't it? An identity tag that gets assigned to a user or maybe an IoT camera on a campus network can travel securely all the way across the SD-WAN fabric. And that very same policy will be enforced when that traffic tries to access an application sitting in your data center or even out in a public cloud. The policy is the same everywhere, no matter what network path the data takes.
What it all boils down to is this. This integration gives you a single unified way to segment your network and enforce your security policy across the entire enterprise. It completely tears down those old security silos that used to exist between the campus, the WAN, and the data center, and it builds one cohesive security architecture that's driven by identity. So I want to leave you with this final thought. For so many years, we've had to design our networks around the limitations of our security tools. But what happens when security is finally unchained from the network topology? When your policy follows the user, not the wire. Think about that. How does that change the way you can build and innovate? What new possibilities for speed and agility does that unlock for your organization?